Hello everyone, welcome back to this channel. My name is James, I'm a computer science graduate turned teacher. And in this video, we're going to look into the fundamentals of programming, specifically using the Python programming language. So this is the chapter outlined. I believe that if you have watched my chapter 12 and 13 videos, which I recommend all of you to watch these two videos before approaching this one, because otherwise it won't be so fun to learn programming because you don't have the basic. And if you have done so, you'll notice that the topics here are quite similar to what we see in chapter 12 and 13. But then we're migrating the knowledge that we learn into programming language. How this video will work is that I'm going to introduce some concepts, and then I'll bring you to this programming platform called Jupyter Notebook to see how I apply this concept in real code, and hopefully you can see the power of programming after this video. So let's move on. Now, why are programming languages needed? They are necessary because they enable the translation of abstract algorithmic concepts. So in the previous two chapters, we already learned how to formulate a solution using pseudocode and flowchart. And now it's time to put into a computer and let the machine execute it. And these are some of the constructs that we learned in the previous video: assignment, sequence, selection, iteration, input and output. We're going to learn how to apply this construct into Python. Python is a multi-paradigm programming language that supports procedural, which is what we'll do in this chapter, object-oriented programming, chapter 27, and functional programming. You don't have to know what these mean, just know that it's a very famous and commonly used programming language. And you can download Python here. Just go to Google and download Python, and you can get it for free and start coding straight away. So some of the key characteristics of Python, before we proceed into programming it, let's understand what it is. It is case sensitive, meaning they look into whether your variable, let's say, is it declared in lower or uppercase, because both lower and uppercase will be treated differently. Mandatory indentation, which is enabled by using the tab button on your keyboard, something we'll see in a while. And they also emphasize on keywords in lowercase. All the keywords that we will be using are all in lowercase. And slicing. Python supports slicing, a technique used to extract specific elements from sequence like lists, strings, and tuples. Interpreted language. It is an interpreted language, as mentioned in the software chapter a few chapters ago. Now, without further ado, let's look into how we can apply some of the construct that we learned into Python. This is how we declare a variable in pseudocode. Declare keyword, the identifier with the data type. But in Python, we do not need to declare the variable because Python utilizes dynamic typing, which means it allows variable to be created without explicit declaration of their data type. For example, when I declare these two variables on Python, I do not need to say, oh, first name is a string, because based on the value I put in, Python will interpret this variable as a string variable. So that's one benefit of Python. And when it comes to variable, we will learn about the difference between variable and constant. A variable is a name data stored that contains a value that may change during the execution. For example, when you're storing the high score of a game. Whereas constant, think of it like a name data stored that contains value that does not change during the execution of a program, like the number of days in a week, the value of pi, etc. So this is how we assign a constant on Python. So in pseudocode, you need to put a constant keyword, but then in a variable, in Python, you do not need to do so. You only have to make your variable name uppercase. So that will tell the reader that this is a constant that does not change. And this is how we assign a value to a variable. In pseudocode, we use arrow, and in Python, we use the equal sign. I will show you how to create this variable in a while. And besides assignment of variable, they allow you to increment a variable in two different methods. This is the way we use in pseudocode. And this is another way that you can do incrementing in Python. So let's move on to our programming platform, Jupyter Notebook. The benefit of it is that I can execute this code box by box. So let's try to do it. So first of all, you can see that I created a constant named pi, assign it to the value. I uppercase it. And I create a variable y and assign it to 12. And what is so special about this y plus equal, it is actually the equivalent of y equal to y plus 1. Meaning I'm incrementing 1 to y. And when I print y, so print is another word for output in pseudocode. So if I were to run this code, you can see that 13 is being output to the screen. And this is just one way you can add it. So we'll explore more, just be patient. Let's go through the concept. The arithmetic operators, we also use this when we are learning about pseudocode. It's almost the same, besides the power, modular, and the division symbol. And they have their respective symbol for all these different functions. So if we were to go back to our programming platform, you can see that I have done all these operations here. This is the division operation, modular, exponential means power, floor division. So once all the value has been calculated, they are placed in this variable respectively, and then I'm printing out. So if I were to run this code, you'll see that the addition showcase, the sum of a and b, which is 13, subtraction 7, multiplication, division, modular, exponential, floor. So I can always change the value of the variable, instead of 10, maybe change to 9, 0. Can see that when I run this code, oh, there's no division by 0, sorry. So I should put it as 1. Great. So you can see that it has done the same thing. So that's all the operator that Python offers. Feel free to try it out on your own. Right. Output. So this is how we output a message on pseudocode. But as shown earlier in Python, we can use the print keyword as such. So if I were to do this, so I put my name as James. My age is 99. I'm an old man. So if I were to print this out, you see that, hello, James, your age is 99. And this is how I do it in Python. So another way of doing it is like that. This is called formatting, placeholder method. So how this works is that you put a placeholder here, curly bracket, 0 and 1, which they will refer to the variable that you put inside the format parenthesis. So input statement in programming, we learn in pseudocode, this allows the program to take in a value from the user. And this is how we do it in Python. The input keyword followed by a square bracket, curly bracket, no, a parenthesis, your prompt. So if I were to show you this, so instead of printing James, my name, we can ask the user for their name, right? So let's say my name is now Steve Jobs. So you can see that the input statement here allow the program to get an input from the user. And I run this, they will say, hello, Steve Jobs, because the input will be stored inside name. Your name is Steve Jobs and your age is 99. So that's input statement in Python. Feel free to try it out. Comment, by so far you can see that I have placed comment here. So the function of comment is not to be executed. Python will ignore a comment if you put a hashtag in front of it. The purpose of it is just for the readers to know what this code do. It enhances code readability. Now let's look into data type, the topic of chapter 13. We got integer, real, character, string, and Boolean, something that you already know. And these are the example of a value in their respective data type. So move on, Boolean expression, which is also something that we've done. Look, its comparison operator is the same as the one we use in pseudocode. And in this example here, I've prepared in my code, let's say I assign x to have a value of 5 and y to have a value of 8. And when you do this, print is x greater than y. And when you compare value of x and y, so this is a logic proposition. It will give you a value of either true or false. In this case, 5 is not greater than y. So the output of this statement here will be false. So if I were to run this code, you will see that it's x greater than y. The answer that is printed is false. X less than or equal to y, true. So on and so forth. This is comparison operator. we can compare also two values using the logical operator. So in this case, I have A equal to false, A equal to true, and B equal to false. And the AND operator, as learned in the logic gates chapter, is that they both of them have to be true in order for A and B to be true, because AND needs two inputs to be true for it to be true. So that's why in this case it will be false, A or B, true because A is true, and not A. It will negate whatever that's inside A, which will give me false. So as you can see, this is what is being output here. So that's Boolean expression in Python. So if you have the good full foundation, this chapter should be pretty easy for you. And these are the comparison operator. The only difference now is the equal sign. When you're comparing two values, in Python, you have to use double equal. And as for the not equal, you have to use, this one. Forgot what the symbol is called. And the Boolean operator, and, or not. So as you can see, Python uses English-like statement. So this is also a key feature of high-level programming language. They use statement that human can understand pretty easily. Now, let's move on to selection. Again, we go through this in chapter 13 already. Basically, based on the condition, the program will determine which chunk of code to run. So this is how we do if-then statement in pseudocode. And in Python, there is a slight change. First of all, you don't have to write the then keyword and the if keyword. And you need to put a colon here. So this is how we execute the same code in Python. And if you have an else statement, look, it's a lot simple. Now, it's the same thing. And nested if statement. Nested if basically means that you put an if statement inside an if statement. So it looks exactly the same as it is in pseudocode, just that you don't have the then, else, and then if keyword. No, you have the else keyword. So this is case statement, something that another way of writing a conditional. So I want to show you how to write if else statement. And I've written a simple program here. First, I will ask the user for a number. If you notice, in this case, I put an int function in front of the input. This means that I'm only taking a number from the user. This is called casting. And after getting a number from the user, I will check whether they meet this condition. I'll print out respective stuff. So let's try to run it. So my age, I'm 99 years old. So you can see that they print you're an adult. But then if I were to run it again, let's say I'm 5 years old, 4 years old, I see that you're a kid. So this is how condition statement can come in handy. Now let's move on to iteration, count control loop. So we have three different types of loop. The first one that we will explore is the fixed control loop, meaning we fix the number of iterations using a for loop. This is how we do a for loop in pseudocode. In Python, it looks the same. It's just that there's just some syntactical differences. So I will explain what this means here. So let's go through it. So the first value inside this parenthesis is the starting value. And this second value is the ending value. But then it will only end, it's not inclusive. That means if your ending value is 6, it will end at 5. So if I print x in this statement here, it will print out 1, 2, 3, 4, 5. Not inclusive of 6. So what if I have a step? So in the previous example, in every iteration, x will be incremented by 1. But what if I don't want it to be incremented by 1? I can use a step keyword, step 3, meaning every time it goes through, increment it by 3. So you can see that first I print 3, followed by 6, 9, until 18. 19 is not inclusive. Alright, step can also be negative, meaning if I want to do a countdown timer, I can start at 10, end at -1, meaning it will end at 0. It will put step as -1. So if we to go back to our code here, this is fixed control loop. You can see that it's print 1, 2, 3, 4, 5. If I were to change it to 10, it will do until 9. If I do it to 100, you can see that it prints from 1 all the way to 99. And if I don't want a step to be 1, I can always write 2. So it will start at 1. The next step is 3. So this is what we call a fixed control loop. Now, let's look into precondition loop, which we express a precondition loop using a while statement in pseudocode. While a condition, do everything here, and while. So this is how we do it in pseudocode. If you translate it to Python, it's not so different. You are only removing the do keyword and also the end while keyword, and everything is the same. So I will show you how one program that I've written. It's a silly example, but hope that it helps you to understand the while loop and how to use it. So I've created an annoying program. So meaning it will just keep printing out the word annoying until I said I don't want to be annoyed anymore. So if I said, do you still want to be annoyed? Yes. They will still print out annoying. Yes. Yes. Until I key in the word no, then it will stop annoying me. And this is what we call pre-condition loop, meaning before they proceed to continue this chunk of code, they will check whether the condition is it true or is it false. Of course, I'm assigning a Boolean value here, but it can also be a condition that will eventually be evaluated to true or false. All right, so that's precondition loop. Let's look into post-condition loop. This is how we do it in pseudocode. We use the repeat until loop, meaning we do something first until we check the condition. That's why it's called post-condition. It's not available in Python, so yeah, we won't be exploring in this video. Which loop to use? So they have a condition that says if you know the number of iterations, use a count control. If you know that the code must execute at least one, use a post condition. But if the condition needs to be checked every time it's enter the loop body, then use a precondition. But honestly, I don't really memorize this. I think once you start programming, you know which loop to use automatically, because sometimes both ways work too, right? Depending on how you code your program. Now let's look into some built-in functions. We have learned function in pseudocode. Basically, they are a module which contains a chunk of code that does a specific task. But there are times when these features need to be used by everybody. This is why Python has built-in function, meaning someone has written the code. All you need to do to use the code is to call the function. So let's look into some of the string manipulation function, meaning function that manipulates string. Right. Let's say I have this sample string called A level CS. And if you want to access a single character in position 3, meaning, look, index start from 0 in Python. That's another thing you need to keynote. If I want position 3, I should be getting V here. All you need to do is to use the sample string, the identifier, square bracket, and put in the index. Very similar to how we access an item in the array, like something that we talk about in chapter 13. All right. Besides, you can also find out the character, return the character whose ASCII value is I, using the CHR function. And ORD function will return the ASCII value of a character. So which is not something that I use very often, so I won't be elaborating on this that much. So the length function, as implied by the name, it will return the length of the string. So A level CS, you can see 1, 2, 3, 4, 5, 6, 7, 8. There are 8 characters here. That's why when you print the length of sample string, you'll get 8 as your answers. Pretty simple. Lower, so if you have the string in uppercase and you just use the function .lower, it will return the equivalent of the string in lowercase. So next, concatenation. If you have two strings, you want to concatenate them. ALEV plus ELCS, you'll get A level CS. So that's concatenation. Basically, you're adding two strings together. So now the next one is leftmost L characters, like the one we learned in array again. So if you were to do this function, square bracket, colon, 3, this means that you want, so when you don't put anything as a starting value, meaning you are taking from the beginning until index 3, but not inclusive. So you are taking, in essence, you are taking the leftmost 3 character. So this will return to you the leftmost 3 characters. And if you want the rightmost 3 characters, there are two ways to do it. First, you can do 5 to 7, 5 to 7, or another way is to use negative number. And negative number is like the equivalent index. So another way you can access the character in a string is start from -1 at the right hand side all the way to the length of string. In this case, if we were to do -3 ... meaning you are taking everything from -3 all the way to the end of the string, which will give you LCS, the last rightmost 3 characters. Slicing in Python, this is how you do it, something I explained just now. You can refer to it. And if we were to go back to our code, so first of all, I ask the user to enter a sample string. Let's say I want A-level CS. So what this code does is it will print out the 4th character, because index starts from 0 of that string. If I were to print out length of sample, you'll see that it will print 8. And if I put everything in uppercase, oops, so it should be sample string. That's another thing. If you name your variable using sample string underscore string, you have to use exactly the same variable, because this is how the variable is identified. So run this, you'll see everything is added. So now let's add concatenation, add the plus symbol to the string here. Oh, again, yeah, you will see that A-level CS being added to blah 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 plus. So this is, if you want the leftmost n character, you do this. If you want the rightmost n character, you do this, df. Ta-da! So these are all the string operation. You don't need to memorize that. You can always check that out online while you're coding. Next up, some of the other functions, including truncating a number. Let's say 3.5 is the value of this variable called decimal. If I were to put int, parenthesis, meaning I will truncate only the integer part of this number. So same goes to converting a string to a number. Let's say you created a string. By the way, string is identified using double quote. If you want to convert it into integer, just put the integer symbol. Float, again, it's the same thing. Of course, there's an error here. It should be float. So let me show you in the programming language. So the first one, I truncate the number. So 9 should be printed, 33, and also 3.5, but in float, not string. So why to do this? This is the result that I will be getting. Now, another function is called random number generator. There are times when you need to generate a random number. And in this case, let's say I want to create a program that throw a dice. This is when I use the ran_in function, and it's from the random library. How do we use this? So first of all, you need to import the random library, which is a bunch of code that other programmers have written. And then you call the function inside the library called random.random. And then, ta-da! And every time I run this code, you will see that a different number will be printed because I'm running a random generator. So that's how you generate a random number. Do try it out. Now let's look into procedure. Some students told me this is complicated for them, but in Python it's relatively simple. You just do a def, stands for function, and identifier, bracket, and then your statement. So in this pseudocode example, this procedure will ask the user for a positive number. Must be a positive number. That's why I use a repeat until. And in Python, you can simply use a while statement here. While number is less than or equal to 0, meaning it's negative, you're going to keep asking the user for that number. So if I were to run this on my code, I've written the function. So I print this. Look, even after I created the procedure here, it's a procedure because it doesn't return any value. Even after I run this code, nothing happened. This is because we haven't called the function yet. So this is why in the next line of code here, I will call the function. You'll see that it's running the code that is written in here. So I'll write a number like -9. It will keep asking me for a number until I enter a positive number like 5. So this is when the program halts, the while loop here. That's another precondition loop example. So this is function. Look, function, as mentioned in chapter 12, is very similar to a procedure, but it returns a value. And in Python, you don't need to specify what value it returns, like the data type of the value it returns. You just need to use the return keyword. And this is the exact same function that we have written, but in a function mode, means return a number. So again, if I were to go back to my code here, I will, let's say, return a number. If I run this thing, again, nothing will happen because I haven't called it yet. But for now, even if I call it let's say I put -2 and enter 5. You will see that number has been printed, but then so this is what we call a function, something that returns a value. And if you don't want it to be printed, you can always assign it to a value like the result equal. So this is something you can do to store a result. And if you want to add the whatever result by 2, you just do this. -5, 7. So you can see that 4, once it's returned to the result, because it's a function, then we can add 2 to it to make the function more useful. So that's the difference between procedure and function in Python, but it doesn't really show in terms of syntax. The only thing that's different is the return keyword. Now, let's look into parameters and arguments. Parameters are needed in procedure and function to provide input, and arguments are passed to a function in programming by specifying them within parentheses. So let's look into how to put in parameter into our functions. All you need to do is to add the value inside the bracket. So in this case, I want to create a function that adds 2's value, and the 2 values need to be provided when the function is called. So I use a and b, result equal to a plus b, and return the result back to the code. So in this case, I have the same thing here. So this is when I declare the function. Nothing happened because I haven't called it yet. And for functions that needs a parameter, you just give some value into it. In this case, 5 plus 7, it should be 12. You can always change the parameter value, and you should be getting a different result here. So this is the difference between parameter and function. So 2 ways to pass parameters. So in pseudocode, you can pass parameter either by value, meaning the value of the variable will not be affected by what happens in the subroutine. Like an exact copy is created, exact copy of the variable is created and passed to the function. So that's passing by value. You can also pass parameters by a reference, meaning any changes involve passing a reference to the original value, allowing modification to affect the original data. Meaning no copy of data is made, you're just passing the reference. So anything that changes that is made inside the procedure will reflect in the variable value change. So I want to show this by explaining in terms of Python code. So if I were to pass parameters by value here, you can see that in pseudocode you can specify that you're passing by value. But then in Python, this is how you can just pass the value in. In fact, you can't pass by reference in Python anyway. So let's say in this example, I'm passing x and y by value here. Look, I will declare this function, and I let my base to be 2, exponent to be 3. So when Python calls this function power, put in the value of base and exponent, what it does internally is that it will copy the value of base and component and put it here. So this is what we mean by passing by value. And then whatever things that happen, so inside the function, if I were to change the base value here to this, it will not affect whatever that is declared here. Okay, so let's say I add this, so x plus equal 1, meaning I'm changing the value of the base and the exponent, and I run this code. And if I were to print out base and exponent after the function have been run, you'll see that the exponent value and the base value will not be changed. Look, it's still 2 and 3. Of course, in this case, 2 raised to the power of 3 is 8, which is what the power done. But then when I print out the base and exponent, you'll see that it's not affected because I'm passing the value, not the reference to it. So this is how we do it, passing by value in Python. Whereas passing parameter by reference, you can do it by using by ref keyword in your pseudocode. But then in Python, it doesn't really have the option. So usually what people do is that after the value have been changed, they will return the value back to, let's say x and y is being passed to this function. And after the value has been changed, they will return the value and assign it to a new variable. All right, so this is how we do it. So for example, I created this function here. Look, what this function does is that it multiplied the value of a by 2, meaning 5 will become 10, b by, it will add it by 10. So 7 will become 17. So you can see that x, modify x, 10, modify y, 17. So this is the equivalent of how to change a variable value, but then you can't really do it without this method. So this is why they say function does not have a facility to pass parameters. So now let's look into array, which is list in Python. Remember, array is a data structure that stores multiple items by using a single identifier. This is how we declare an array in pseudocode. And to do it in Python is very simple. You just need to draw a square bracket. So in Python, there's no array, there's only list. And Python uses a dynamic list. It means that it is a mutable data structure that can grow or shrink dynamically in size during program execution to accommodate varying numbers of elements. Look, when we are declaring this list here, we don't need to specify the size because it's dynamic. Every time I add an item, the list will automatically increase by 1. So if you can see here, when Ali is added to the list, the array will expand, expand, and expand. And of course, another thing I want to say, to add something into the array, to the list, you just use the append keyword. So in this case, I've written the code here. So if I were to print out the friend list, you will see that the list will contain all the friends that I have. Yeah, Ali, Bush, and Catherine. And you can also, going back to the explanation, you can also access the item in the list by using the indexing method, which we talked about in chapter 12. So if I were to print this out, you can see that Ali, Bush, and Catherine has been printed. So that's 1D array, nothing really fancy. And for 2D array is another thing here. So this is how we declare 2D array using pseudocode in Python. Again, it's very similar. You do a square bracket, and because it's a 2D array, meaning 2D list, meaning you have a list inside a list. So you can see that this is how I put the list inside the list, and this is a visualization of what happened behind the hood. Of course, if you want to access the element, simply refer to the index. So 0, follow the row number, followed by the column number. So 0, 1 will give me 2, and 2, 1 will give me 10. So I have already written down the code here. If I were to run this code, and then it will give me 2 and 10, which is something that we look at here. Now, last part of the chapter, which is writing and reading to a text file. I don't think I'm very clear when I'm in the pseudocode video. So this is how we write something to a file, but in Python, this is how we do it. And it's quite magical, and I want to show you that. All right, before that, I forgot this part. Before moving to text file, remember last video we created a connect for code. So this is the code for connect for. And then when I run this is a function, very, very long. You don't have to know how it works. And then when I run this code, you can see how we can create a game in Python using the pseudocode that we've written in the previous 2 videos. So if I were to play X, I'm going to do 1. You can see that 1, X will be placed here, and 2. So this is a game that can be continuously played. So this is how, if you look at the code, all they use is just 2D arrays, 2D lists, and then for loop, if statement, etc. I mean, if you want to challenge yourself, feel free to write this code out from scratch. I believe that's the way to learn, because the purpose of this video is merely to provide a fundamentals to all the syntax and to do problem solving. To improve your problem solving skill, you still need to code a lot of programs you want to code yourself. Okay, so that's about it. So I'm gonna cancel this program. Let's look into what we were talking just now, writing to a file. Meaning I want to write something from here. This is a line of text to, let's say, a txt file. So how I can do it is that I use the open keyword, meaning it will open a txt file for me. So this is the directory I'm in. Now it has nothing. But then if I were to run this code here, I'm saying open a file called open output.txt, write this line of code, of sentence into the file and close the file, you will see that the output.txt file has been created. And we'll have to open it. This is the line that I've written. Of course, if you don't like this, you can always add something and just add in some random text here. If I were to run this, you'll see that this line will be reflected when I press the reflect button. Look, everything I've typed. So this is the essence of writing something to a text file. Now, let's look into reading. Besides writing, you can also read from the text file, meaning reading everything here into your programming code. So in this case, I want to read whatever that is inside output.txt, and I'll use the read line function, and then I'll print out the line I read. So you can see that everything that I just written have been read from the file. So last but not least is appending. So meaning you add another line of text to the file, to the existing file. So in this case, when I run this code, you'll see that actually this is why I write. This is another line of text. If I have to refresh it, this line will be reflected in this output.txt. So this is how we write, read, and append to a file. And I believe that's about it. All right, another way to append something to the file, you can look at it. So I believe this is the end of this Fundamentals in Python video. Let me know if you have any question. I'll probably post up an exercise that I've created for my students so that you can practice solving different questions using the programming construct we have learned today. And thank you so much for watching. I will see you in chapter 15. Goodbye.